Assalamu alaikum warahmatullahi wabarakatuh. My name is Sirajuddin Bakhtari. For our group project, we're going to analyze the factor that has effect on student academic performance. Based on our data set, we have about 409 data sets which have 11 attributes. The first attribute is about gender, which is male and female. The second attribute is race, ethnicity. We have 5 types of ethnicity here, which is A, B, C, D, E. The third one is parent status. Here we have A, T, that stands A to apport. T is for together. The fourth attributes for our dataset is parental level of education, which has bachelor degree, master, and high school. The fifth one is we have here lunch quality, which is a standard and free lunch. The address, as we can see here, we have internet, the use, yes or no, the number of absent, and also this is the things the student got in final, the score and final result. Thank you.
Assalamu alaikum, I'm Iman Ahmed, and now I'm going to show about data rapid minor processes for our project. First we have to import the data set from our local repository. So this is our data set, and then we have to select all the attributes here, and then for this process we have to change the data types. In the parental status we have apart and together, so we're going to make binomial, and also for the lunch, which are standards or free, just 2 types, so we're going to make it binomial. And then we go to next process, then we save it. So all the data has been loaded. Now we're going to the design panel. Now we have to drag the data to start our process, and if we see in the statics, our data set is quite clean. So we have just two types of gender and 5 groups, and parental status. And for our process, if we see the parental level of education, there are 6 columns. So out of that, there is one high school and some high school, so we're going to make it 1 rather than 2. So for that we have to replace, we have to use the replace operator. To connect it, so replace some highs. So it's just on the high school. To make the final connection also. So after doing that, so we can see now it's become only one high school. Now to continue our process, we have to generate an attribute in our data set. We have 3 kinds of scores for student: math score, reading score, and writing score. But for our process, we are only going to choose math score to validate our model. So in the general, we're going to name it as performance because it's for the condition, and then we're going to use the logical operators in condition, and then we're going to use math score. If the math score is greater or equal to 55, then we're going to say the student performance is good, else performance is bad. I'm going to apply. So the column has been retrieved, and now we're going to select use the select attribute, because we're not going to use all the attributes for our model. So in this way, to subset and then select attributes, we're going to use gender, range, parental status, performance, and level of education, race and ethnicity. There are 5 races. The rest are not that important. Even absences, it has no influence on our model and our project, so we're not going to choose it. And then we have to add a set row. And then we choose the performance as our set row on this level. And now we're going to use the decision tree. To see, and for that we're going to use the information gain, and I'm going to put this 15, and the confidence I want to put it 0.5, and the minimal gain is 0.4. And so our decision tree has been loaded. So this is the decision tree. So this is our decision tree that's been generated from the process.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ali Akbar Tajik, and I'm going to explain about decision tree that you are seeing right now. So it looks little complicated, but I will simplify it. So firstly, our root is language. So the language is the most important thing. It has been chosen by the Bitminer. So in here we have 2 parts. Which one is like the students which has taken standard language. Their results are all the time good. So like we have a little like bad result, but it has a very big effect on the student's performance overall. Yeah, and the second part is like free or reduces lunches, like let's say the junk foods when they take it. So then we have of course, as we said, like in the data set we have 5 different races, like in group A, B, C, D and E. So in group A like mostly the result is bad. In group E the result is usually like good. Yeah, when they are having like good lunch, free lunch, and the race E has a good result. And I'm going to explain the group D. In here, the overall, like if you see this area, the very important part is like the parental status. We have 2 different parental status, which are the parents which are living together and the parents which are living apart. So when the parents are living together, usually the result is very good. And if the parents are living or they're living in different places, they're divorced or whatever, it depends on their gender. If they're male, like usually, like mostly the result is good. And if they're female, so they're more emotional, and that's why their result is not that good. And And also in race group B and group C, the main themes are parental level of education. As you can see in this area, so the parents who are graduated from high school, their students' result is bad in group B, and at the same time in here, the same thing goes here. As you can see, when their parents are their parental level of education is high school, the result of the students will be bad. And second thing is like when parental level of education is associate degree in group B, it's like, you know, the gender is the main factor in here. The female students will have bad result and the male students will have good results. But in group C, race group C, when their parent level of education is associate degree, usually, like mostly it is, they have a good result. So if I want to conclude, like, you know, to our overall understanding from this decision tree is the parental level of education affects on a student's academic performance. And secondly, a standard lunch habit has a good effect on a student's academic performance. As you can see in here, it has a very good effect. And lastly, a student's academic performance affected by parental living status, because they have their parents, when their parents are living together, the student's performance will be good. And when their parents are not living together and they're living in two different things, it depends on their gender. So when they're male, they will have a good result. When they're female, they will have a bad result. So that's all.
Assalamu alaikum. I'm Shamim Ahmed. As Imran explained you guys how we did our data preparation, now I'm going to explain how we use this in two data model technique to find out the accuracy model of our student performance. So first, you have to search validation, where you have to drag split validation here. Then you have to connect the first one model with the first one, then the second with the second one, the third with the third one. Then you double click it. First you have to drag the decision tree here. Decision tree. Where you have to connect this one to this, and you have to connect this to model and express threshold. Then you have to bring apply model. Then you connect this one like this. You bring performance. You have to also connect this threshold to this one. Then you bring performance. Classification. You have to connect this one to this, level to level, and this one to this one. Then you go to the decision tree, where you have to put according to our data preparation information gain. You put 15, you can put 0.5 and 0.04. so if we run this one, as you can see, it shows an error. We have to just connect this input connection, then after then you can run. So for decision tree, our model shows the accuracy of 81.97%, where it shows like we are thought 94 students would be good, predicted to be good, but we found out that 6 students which are predicted to be good turned out to be bad. And here we thought total 28 students predicted to be bad, but we think that we predicted 12 students to be bad, but they are turned out to be good, so it should be goes here. So these are the accuracy model. Decision tree for 81. Actually, these 28 students which are turned out, which we predicted to be bad, but here it shows 16 students which is predicted to be good, but it goes, it should be goes here, not 12 students. So this is our accuracy of the decision tree model. Now we're gonna apply the second technique of our project. So here we goes to the validation. We have to change this decision tree. We're gonna apply our second technique. Second technique is naive Bayes. So we delete this one. We bring naive Bayes. So we bring naive Bayes. So we run this one. It shows missing connection. Okay. So you just have to connect this one to this and this one to this. Then you run again. So as you can see, guys, we found for our naive Bayes accuracy is 70.0.5%, where we can see that we got 94 students which are predicted to be good. So we got 4 students bad. So these are the 4 students which we predicted to be good but turned out to be bad. Here we found total 20 students turned out to be bad, but it shows only 4. So these 24 should be here. So total 28 students turned out to be bad. So these are the accuracy model of naive Bayes. As you can see, our decision tree accuracy was 82%, and our naive Bayes accuracy was 77.05%, though kind of similar. So it's good for our model. That's it all from us. Thank you everyone.